Here we're going to look at two special types of lines, horizontal and vertical lines. So sketch a graph of a horizontal line at 3 on the given axes. So horizontal meaning straight across. I'll go up to a value of 3. Go straight across. And there's our line. Write the coordinates of any 2 points on the line. Well, any 2 points, if I just take, for example, 1, 3, so I'll take this point, and let's say 5, 3, I'll take that point. So if I use 1, 3, and 5, 3, what you might notice is that the y value in both of these is 3. So when we find the slope of doing y2 minus y1, so 3 minus 3, divided by 5 minus 1, notice what happens. We get 0 over 4, which is 0. No matter what your points were, as long as they were on this line, the y value was 3, which means when you subtract 3 minus 3 in the numerator, you're going to get 0. The x values for your 2 distinct points will be different. So whatever you put in there for x, your denominator may be a different number, but when you divide 0 by a non-zero number, you end up with 0. So no matter what 2 points you chose, you would have ended up with a slope of 0. Now notice when you count the slope, to get from 1, 3 to 5, 3, how many up do you have to go? What's the rise? Well, it's 0. You have to go up 0. And then to the right 3. I'm sorry, to the right 4. Okay, so what is the y-intercept? Well, we can see from the graph that the y-intercept is 3. So when we write the equation of the line in y equals mx plus b form, we know that y equals, the slope is 0, times x, and then plus b. Well, we know that plus b is 3, don't we? So y equals 0x plus 3. And what's 0 times anything is 0. So we end up with y equals 3. So it turns out that that's the equation of your line. So a horizontal line is always going to be y equals a number. If we chose to put the line down at -4, then it would just be y equals -4. Number 2, now we're going to look at a vertical line at -5 on the axes. So here we're going to graph a vertical line at -5. The coordinates of any 2 points. So let's just say -5, 1, and maybe -5, 3. So notice in this case, this is just the opposite as what we had before, where the y value was the same. Now the x value is the same in both points. If we were to go through and find the slope, 3 subtract 1, divided by -5, subtract -5. And that's 2 over 0. Now we have 0 in the denominator. So when you divide 2 by 0, what do you get? It's actually undefined. If you put that in your calculator, 2 divided by 0, you end up with an error. Okay, that's what we call undefined. How many times does 0 go into 2? You can't do it. It's undefined. What is the y-intercept on this? Well, looking at the graph, there is no y-intercept. The graph is over here. There is no y-intercept. There's an x-intercept, but not a y-intercept. So there is none. So now, if we write the equation of the line, what I would always suggest is you want to think of y equals mx plus b. So anytime you're trying to write the equation of a line, I will always tell students think y equals mx plus b. That's your slope-intercept form. It worked okay in the first case where we had a horizontal line. We end up with y equals 3. But now when we try it in this one, we have a slope, which is undefined, we don't know what it is, and a b value of none. There is none. Don't confuse none with being 0. If the y-intercept or the b value was 0, it'd be passing through right here at 0, 0. That's not what's happening. So don't confuse none with 0. Not the same thing. Okay, so how do we take care of this? Well, this is the only case where trying to use y equals mx plus b and substituting numbers in is not going to work, because we have an undefined slope. You can't define and you can't multiply an undefined number by x. So that's a problem, and also none for the y-intercept, that's also a problem. So this is the case where we need to think about it. Notice in the first case when we had a horizontal line, notice what happened with our equation. The y value was always the same, and in our equation, y equals 3, because the y value was always 3. Basically saying it didn't matter what x was, the y value had to be 3 no matter what. So in this case, what's happening? The x value is always -5 no matter what y is. So the equation of this line is a special one of x equals -5. If we were to draw a vertical line through 1, that would be x equals 1. A vertical line at 4 would be x equals 4, and so on. So the idea here, the slope of a horizontal line is 0, so the slope is 0, and then the equation is always y equals a number. For a vertical line, the slope is always undefined, and the equation is x equals a number.